Welcome to this webinar. My name is Daniele Posenato and today I'm here to present the DiView software. During this webinar, you should hear my voice through your PC speaker headset. This webinar will last about 30 minutes. You can ask questions using the question panel on the right of your screen. We will answer using the question panels or at the end of presentation or by email. Later this week, you will receive a link to the presentation in PowerPoint, the video recording of webinar. The content of this webinar are the following. I will speak about the DiView with an introduction of the software, DiView Architecture, the DiView feature, speaking about the different version of the DIView Full and DIView Lite, the DIView kernel interface, DIView-Client interface, DiView Configurator, DIView bulk measurement uploader, the DIView 2 distribution, that is what you receive whenever you order the DIView software, and then there will be the conclusion. What is the DIView? The DIView is a unique solution for managing data from distributed fiber optic sensing system. The main DIView features are importing measurement data to a single database, management of multiple measurement units with multiple channels, processing data to apply calibration and selected zones of interest, alarm generation based on complex criteria, for example, leak detection, communication of alarm through relay and to SCADA system, management of alarm acknowledgement and multiple users, data visualization on map with color coding, real-time update of data, alarm and visualization on map and tables, easy configuration by end user with no programming needed. The main objective of the DIView is to show the status of a distributed fiber optic monitoring system. Now a couple of slides of the final results of the DIView are shown. In this particular slide, there is the distributed temperature of a pipeline in which is visible one leakage point. In this slide, instead, there is the distributed temperature on text with a visualization based on scale of color. You can see the temperature is in different color based on the scale of color predefined on the software. The DIView version. The DIView software can work in two different configurations based on the type of license. There is the DIView Full that has no limitation. The real-time data visualization and refresh. The user is able to see real-time the status of the entire system, and then event detection, for example, pipeline leak detection or settlement detection. The DIView Lite instead is a free version of the DIView with limited functionality. In particular, it can only manage a single readout unit. It allows only static visualization of manually imported data. It does not provide a real-time data analysis, and there is no auto-refresh of data visualization. More in the details about the DIView Lite feature, it is useful to import measurement data to a single database, processing data to apply calibration and selected zone of interest, data visualization on map with different color coding, easy configuration by end user without no programming needed. The DIView architecture. DIView is designed for distributed measurement data storing, processing, representation and analysis, as well as for control of single or multiple datasets and item reading unit at the same time. DIView is also used to store and manage data in a centralized interface. The software is based on several applications. The data streamer, reading and downloading of collected measurement by the reading unit. Typically, this software is installed on the DTS. The DIView kernel is the core, and it is in charge of data processing and storage of data processed on the server. DIView-Client, it is a multi-language graphical visualization of data and alarms. DIView Configurator, it is a tool to customize the software through a user-friendly interface. Bulk Management Uploader is a tool to upload and process the reading unit measurement offline. In this slide, there is the most general architecture of the DiView. So we can have several reading units that are acquiring the data from different channels, so different fiber optic installed on the site. And then the data are written using a data streamer that is writing the last measurement taken by the reading unit on a database. The database that we normally use is an open source database, is Postgre, and it is a database where all the data are saved. So, resuming, the streamer is a software, is a tool that is on the DTS that is always writing on the database the last measurement taken by the reading unit. The DiView kernel is the core of the DiView, and it is typically installed on the server. It is the software that is in charge for the data processing. Then there is the DiView Configurator. The DiView Configurator is a tool that is necessary to set up the system. It is a tool quite user-friendly, just to set up all the full monitoring system. So from the creation of the database to the configuration of the relay. So with this tool, you can configure all your system. Then we have the DiView-Client. The DiView-Client are the user interface used by the final user to have an overview about the status of the system. These visualizations are customized on different languages based on the selection made by the user. Then we have the bulk measurement uploader. This is a tool to upload offline the measurement taken by the reading unit. So the DiView-Client is a graphical interface used to navigate through the views of the entire installation. It provides a real-time data visualization and also the visualization of the history of the project in form of map and graphs. Here we have, for example, an overview of a pipeline in which we have a report of the measurement point. Whenever you move the mouse and then the mouse is close to a measurement point, you will see the report and the status of the measurement point. At the same time, you can also zoom in, zoom out the map to see more in the details of each measurement point. In this slide, there is the log history report, and then the aims of this report is to present on a table all the warning of the system. The main information shown on this table are when the alarm occurred, the type of alarm, so the threshold that has been overtaken, and then who did the acknowledge and the stop. As you see here in this table, there are different colors, so different row with different color. White are the alarm that are not anymore in progress, so their alarm has been just acknowledged and stopped. In red, we have the pending alarms, so the alarm that are still waiting to be acknowledged by an operator. And in yellow, we have the alarm that have been acknowledged, and then they are waiting for the stop by an operator. Also, there is an indication of the sensor and then the location of the point, where the point is located in the client coordinate system. In this slide, there is the system log report, and then it contains all the log referred to the status of the monitoring system, showing, for example, event as timeout of a sensor or fiber break. So whenever there is a problem on the monitoring system, there is a new row that is visualized on this report. In the DiView client, there are several tools to graph the historical data. In particular, there are 5 different tools. So one, it is for viewing the raw sensor. It is a graphical tool to view the data collected by the DTS system, so the data without any post-processing. Then there are the visualization of a real calibrated sensor. So they view the data collected by the system and then analyzed by the DiView kernel. Then there is evolution of single measurement point. It is a tool to visualize the temperature evolution versus the time of a specific measurement point. Raw sensor history playback is a tool that allows to select a group of measurement and to play in animation so that you will see one measurement after the other what was the sequence of your measurements. In this, this is the typical drawing, the typical windows for the visualization of the raw measurement. It is composed by different in different parts. In the top, in the bottom left, there is a calendar where you can select first of all the sensor, and then you can select a specific day. Whenever you select the day, you have the available measurement list in which there are all the measurement taken at that specific day. In the selected measurement area, there is the group of measurement that had been selected, and then this group of measurement are the ones that are visualized on the graph. On the graph, you have the possibility to perform the zoom and to move the graph to see more in the details, specific portion of your fiber optic cable. You will see also here an icon on the bottom right. There is a picture, and then whenever you click on this icon, there is the possibility to refresh all the map, uploading on them the status of the system at the precise timestamp identified by the selected measurement. So you can select one measurement and then you refresh all the maps of the system based on that specific timestamp. Another option of or another function of this history plot is the possibility to perform the zeroing. So you have the possibility to select a reference sensor, a reference measurement, and this reference is subtracted to all the selected measurement. So in this specific case, there is a group of 5 measurements, and then there is a reference, and this reference has been subtracted to all the others. So at the end, you will see what is the deviation from the group of measurement that you selected respect to the one that you select as a reference. In this slide is presented the single point evolution plot. It is a tool to visualize the temperature or strain evolution of a measurement point. It has the same structure as the other, so you can select the real sensor that you would like to visualize, the day, and then whenever you select the day and the sensor, you have the available points. So there are the list of measurement points that are the component of the sensor. Whenever you select your available point, you have the possibility to see what is the history of the measurement point that you have selected. In this specific example is shown the temperature evolution of the ATTS system, where every hour there is the cooling cycle. So you see that with a window of a period of 1 hour, you will see the cooling of the temperature. The raw sensor history playback is a tool to play the historical data on a graph. In this window, you can select the period of data, and then pressing the play button, you have the possibility to view an animation. In particular, so you have the possibility to select, to pick up, to specify the sensor, to define the period of measurement that you would like to see, and then with pressing play, the animation starts. In doing the animation, you can do also the zoom, so you can focus your attention part of your measurement, You can also change the speed, so you can change what is the refreshing rate of your animation, and then also you can set the reference. So you have the possibility to subtract the first measurement to all the others, so that you are able to see what is the difference between your reference and then the rest of the measurements. The DiView-Client also have an area for the management. So there is the possibility, first of all, to do the login, but also there is the possibility to perform other more complex actions. For example, to create a new user, modify the property of the user, change the password. There is also the possibility for the alarm setting. You have the possibility to tune or modify what are the alarm criteria. And then also you can enter more in the details, removing, for example, some measurement point from the post-processing. At the same time, you have the possibility to do the logout, and then also to return to live data whenever you have selected to visualize an historical status of the system. You need to return to live data refreshing of your system. There is an icon to allow you to switch again to live visualization of the data. Always with the DiView-Client, you can manage the user of the system. You can select also the visualization language of the DiView. This means, for example, that the DiView automatically switches to the selected language whenever a user does the login. Language that are supported by the DiView up to now are, for example, English, French, Italian, Spanish, and Chinese. And also you have the possibility to specify what the user is allowed to do. There are different class of user. There is the simple guest user that cannot do any action on the system. There are other users that are in charge only for the acknowledge, other acknowledge and stop, other that can modify the threshold or the alarm criteria, and other that are in charge also to create other users. So there are different type of user according to the operation that they are allowed to do. Coming back to the language, it is one of the main feature of the DiView tool, so that for each user has its own language. Whenever the user does the login on the system, the DiView switch to the language that has been selected. So all the pop-up, all the icon, all the message on the software are in the language that have been selected for the user. Always with the DiView-Client, there is the possibility to perform the tuning of the threshold. You have the possibility, first of all, to disable the alarm criteria, and in particular, you can disable the absolute threshold, and then you can set the new threshold for this criteria. Then you have the deviation from average, so you can disable, and change the threshold for these specific criteria. And then you have also rate of change, in which you have several rate of change criteria, and then you can disable, or modify each rate of change criteria. This panel is available only for the people that has the right to change the threshold of the sensor. A map is an overview of a part of the system. In this slide is shown a map with a point in alarm, and it is indicated by a red flag. There are different, if you see in this slide, you will see that there are different tabs. So each tab corresponds a map. The tab in red means that there is a point on a measurement point on that map that is in alarm, and then you have the two ways to visualize that there is an alarm: from the tab, and then in the map itself, when in the location where there is the red flag. In this slide, instead, there is the same another visualization in which we have the map, in which we have a yellow flag. This indicates that there is a point for waiting for the stop, for which the user had already done the acknowledge. You see there are different color of the tab. So there is the green tab, it means that all is working properly. Red tab, it means that there is an alarm in progress. And the yellow tab, it means that there is an alarm already acknowledged but waiting for the stop. Whenever you move the mouse close to the measuring point, a report appears, contains the main information of the point. In particular, the report contains the sensor name, location in the client coordinate system, the last value, and then if there is an alarm, the type of the alarm and when the alarm has occurred. Also with whenever you are on the map, you have the possibility to zoom in, zoom out, and then also to move the mouse, the map using the mouse, so you can see more in the details the status of your system. In this specific case, there are five points in alarm. There are different visualization on the DiView client. The different visualization in which you can visualize the point, the measurement point on a map. You can have, as in the previous slide, a simple visualization using green and red. It means that green, everything is working fine, and red, there is an alarm. Or like in this case, you can have a scale of color. The software allows the customization of the rainbow, so you can select your own scale of color. You can select also the number of ticks that you would like to divide your rainbow, and then at the same time you can define what is the line width. So you can, as you see from these two slides, the line has different width. So that's a simple parameter of the software. You can define if you would like to see the results in green or red visualization or in scale of color. And then at the same time, you can easily change what is the line width of your visualization. The DiView Configurator. The DiView Configurator is a unique user-friendly tools for the configuration of the monitoring project. No programming is required, and then it aims to be a real user-friendly tool, and it allows the definition of reading unit, raw sensor that are connected to the reading unit, and then you can specify the main properties like timeout, what are the relay controlled in case of a problem on the raw sensor. Then you can specify the real sensor, indicating what is the calibration, what are the section of the sensor, what are the warning criteria to apply to the sensor, and also to the relay that should be controlled whenever there is an alarm condition. Then you can define also the maps, so you can specify what are the background, what are the sensors that are visualized on the map, what is the line width, and then the scale of color. You can also have the possibility to set up the relays, and then also to get the report on how the relay have been assigned to the sensor. And then also you can set what is the group of user of your project. So you can create, modify, and delete user. And then there are also other project options, like, for example, title of your project, license, comport to use for the relay. The real sensor, it allows for, this is just a part of the configurator. It allows to configure the properties of the real sensor, such as timeout, and then the zone or section of your sensor. It can, for example, specify what is the raw sensor to use, and then which part of the raw sensor should be considered for the alarms. Not all the part of the raw sensor are really interested. There are, for example, just connection cable that can be removed from the sensor. So in the real sensor, at the end, you specify what are the active zone of your sensor, what the part of the sensor that are in charge for triggering alarms. Then in the alarm criteria tab, there is the possibility to specify which criteria are active. In particular, you can select absolute criteria, if it is active or not, and then the threshold to use. The deviation from average criteria, so if it is active and the relative thresholds. And then also the rate of change. You can define how, as many rate of change criteria as you want, and then you specify the threshold to use for these specific criteria. Rate of change, it means to compare the last measurements with the measurement taken previously. So you just calculate the difference between measurements. In the third tab, it is a relay configuration, and you can specify the relay that should be controlled in case of alarm. In this specific case, the relay 25, 26, 27, and 28 are the ones that are controlled by the real sensor whenever there is an alarm on this sensor. The main properties, whenever you create a map, you need to specify what are the main properties of the map. In particular, you need to select what is the background to use for the map. You need to specify what is the type of visualization, that is, for example, green or red, or based on scale of color. You need to specify, and then in this case, you need to specify your list of color that you would like to use in your rainbow. And then also you need to specify the map name, so the name of the map that you will see on the DiView. Whenever you have created or once the map has been created, it is possible to proceed with the drawing on the sensor on the map. On the map, you can indicate the sensor to plot. You can select more than one sensor. So in one map, you can plot several sections from different real sensors. You can specify also the landmark and the passing point. So the difference between these two, it is just passing point. You just indicate that the line need to pass for a specific point. And then landmarks, it is a point for which you know the distance from the unit. You know exactly, you have a perfect matching between the point on the map and then the distance from the reading unit. On this tool, you can also play with the alignment on the segment, so you can just to have a perfect line, so to be more, let's say, straight for the visualization. So summary and conclusion. The difference between the DiView Lite and the DiView Full are resumed on this slide. Basically, the Lite has the following restriction. It is for static visualization. It is only for one reading unit. It is only for one raw sensor. It allows only one map. And then the user can upgrade to the full version at any time, conserving their data and the configuration. Whenever you ask a copy of the DiView, you will receive a box that contains a flash drive in which are available the DiView kernel, the DiView-Client, the DiView Configurator, the bulk measurement uploader, and then there is a folder with the videos explaining how to install and how to each tool of the DiView works. Then there are a folder with all the manuals, some data, some example of data that you can use to play with the DiView, and other tools that are necessary in case you need to open the measurement or the manual in PDF. If you would like to have your copy of the DiView Lite, you can just send an email to info@smartec.ch, or you can just call directly SMARTEC. Conclusion, the DiView is a unique set of user-friendly tools for the configuration and management of distributed fiber optic monitoring system. It is designed for continuous monitoring of temperature and strain. It is available in two versions, Lite, a free version of the DiView with limited functionalities, and the DiView Full, in which there are no any restrictions. The DiView has been deployed in 10 of projects worldwide, so it is, and then it is our, let's say, the software that is still constantly updated, and then it is the more tested. Okay, the webinar is arrived to the end. I hope you really enjoyed the presentation. Now we will answer to all the questions posted during the presentation. Bye-bye, and see you at the next webinar.